Hi students, it's Dr. Marks, and I want to take a few minutes to walk you through a parallel example of the kind of thing that you're doing in data analysis number 2. Now, if you remember, we're focusing on hypothesis testing. So don't confuse that with confidence intervals. That is kind of a related idea, but we're doing hypothesis testing. And so I want to walk you through the idea of doing a hypothesis test in Excel. But I've created my own data set. So let's suppose I have this data set like you see in front of you, and this is going to be students. I know students' gender, I know what country they're from, I know their test scores on some standardized tests, their age, if they're female. I've created that dummy variable right here. You see that in E, and I've got my categorical dummies for countries. I've got 4 countries, so I need 3 categories. But I want to go through just one simple example here. And that is, we want to know, are males and females scoring similarly? Is it that males score better than females, females score better than males? We need to investigate this. So the first thing we need to think about is, should this be a two-tailed or a one-tailed test? Remember, we use a one-tailed test when we have some reason to think that one mean is going to be greater than the other. But I don't really have an argument for if I think males would score better on a standardized test versus females, or the other way around, females better than males. So without some kind of real reason to think that the means should be different, I need to run a two-tailed test, as it says right here. Now, I've got to be able to write up my hypotheses, and these are not written up very well because I'm sitting here in Excel, but I'm going to expect you to write these up better looking. But my null hypothesis is simply that the means are not different. The means are not different. The alternate hypothesis is where you put the difference. So if you think there's a difference, that goes in your alternate hypothesis. If you're testing for a difference, that goes in your alternate hypothesis. So my alternate hypothesis is that the mean for males is not equal to the mean for females. Now, I had to write it out because I'm Excel and I can't remember if I can even do a less than an equal sign. Probably I can somewhere, but it doesn't really matter. You get the idea. So the first step is we need to have a hypothesis, and that hypothesis needs to be either one-tailed or two-tailed, and our hypothesis test is going to, our results are going to be determined by, in part, if it's one-tailed or two-tailed. So I need to think through that first. Then I need to craft the appropriate hypotheses. Okay, so I've done that. Now, based on that, clearly I need a mean for males and a mean for females. But here's the deal. You're not going to calculate the means yourself. We're going to let Excel do all of these things because Excel needs to look at not just the means, but the number of observations, the standard errors, and it's going to do all that for us. So if anyone's trying to calculate the means and calculate standard errors and all that, that is not what we are going to do because the data analytics tool pack can do it for us. All right, let's look back at my spreadsheet information, and I've got scores here. But I need males divided from females. The easiest thing to do is take your dummy variable, and I've got a dummy variable that's 1 if female, and I'm going to say, I'm going to come up here to my sort button, and there might be better ways to do this, but I'm just going to do this quick and dirty, and I'm going to say, look, I want to sort largest to smallest. Now, you see it asks me, do I want to expand the selection? All that means is it's going to keep your rows together. You want to say yes. So we're going to expand the selection, basically saying, look, when you reorganize this, keep all of the row together. So I'm going to say sort. All right, boom. Now you see I've got all of my female observations on the top in the yellow section, and I've got all the male observations below in the green. Now I'm ready to do a hypothesis test. So I'm going to test if the mean test score is different between males and females. Now to do that, I need my data analytics tool pack installed, and hopefully you've done that. And when I installed mine, I was kind of hoping it would bring it right here on my little green ribbon at the top, but it doesn't. It sticks it underneath this data tab. So if you've installed it and you don't know where it is, maybe it's there. On the right, you see here, I've got my analysis tab. So I'm going to click on my analysis tab, and now I get a menu. You've got lots of options here, but we're interested in doing a t-test of a two-sample. Sample means assuming equal variances. So we're going to work under that assumption for now. We're not going to ever look at unequal variances. This is just trying to keep it simple. Okay. Make sure you're not accidentally choosing the paired two sample means. So that would be like if I gave students a pre-test and a post-test, and then I looked at the difference just between pre and post for person one, pre and post for person two. That's not what we're doing here. We're not pairing two observations together. All right, so I'm going to hit OK. I need my t-test for my two sample under the assumption of equal variances. So there I go. All right, let me get all this out. I've already done this once before, so it has cells in here. Clean it up. Okay. Now, stop. All right, so let's say that I end up with this blank page like I have here. The first thing I'm going to do is give it my variable 1 range. So I can click and drag and then let go. Boom. So it's picking up the observations between C2 and C19. Those are my females. And now I'm going to click on variable 2 range, and I'm going to do the same thing. I click, and I'm dragging. All right, and then I'm letting go. Please double check, though, and make sure that everything is as you want it, because if you miss a cell, everything's going to be wrong. You might still get the same answer, but you're going to be working with the wrong number of observations. Okay. Now, I don't have data labels here. I could, if I put in a row, I'd have some data columns with labels, but it's not a big deal. I can change my labels later, so I'm going to leave that blank. You're going to have to pick an alpha. Let's say I want to be 95% confident, so I only want a 5% chance of error, right? And then you have to tell it where you want to put it. You can tell it what output range, or you can tell it new worksheet. I'm just going to stick mine in a new worksheet. So I'm going to hit OK, and boom, I have a new worksheet. I would suggest that you rename these so that you can find your stuff later. So this is going to be females versus males. Okay. Now, this is not very readable, so I'm going to move this around. One thing you might think about is that we don't really need all these different decimal places, right? I mean, that's a level of refinement that I don't need. So I'm going to come here to the home page. I can click on this button, right? You see that little decreased decimal pop up? Decreased decimal. So I'm going to say 1, 2. Personally, I like to carry, let's say, 2 decimal places. Now, if this is something like medical research, maybe I want just an incredible level of precision, but it should be fine. So I'm going to do the same thing here. What's going on? Oh, I don't like what I just did. Let me just get back out of that. Okay, just going to do it one at a time. Okay. There we go. All right, you get the idea. Now, notice it says variable 1 and variable 2, and if you don't tell me what those are, this is going to be a problem. I know my variable 1 was female, right? Because I had the females at the top, and I know my variable 2 was males. So you need to make sure you have this correct, and I probably need to give this some kind of a title, right? Because male and female what? Are we talking about how long it takes them to do a 50-yard dash? No, we're talking about standardized test scores. Okay. Now, remember our hypotheses. Let me come back over here and grab them. We're doing a two-tailed test, right? Let me just paste those right here so we have them. Okay. Now, remember, guys, you have everything you need. Now, notice here, hypothesized mean difference. We don't really need that. When I was completing the little, file and giving my ranges and giving my alpha level, if I wanted to say, like, I want to test if the difference between males and female test scores is 5 points, then I'm looking at some hypothesized difference. So I don't think I really need that, so I can just get rid of that if I want. Okay. Now, obviously, we said we're running a two-tailed test, so this is going to be the stuff that's relevant. I could probably get rid of the one-tailed, right? Okay. Now I've got a table that takes up a lot less room, right? So I can even move things over. Okay. Now, let's make sure we remember what we're doing here when we do a hypothesis test. I've got, and I understand we have our t statistic and we also have our p-value, but I want to do it both ways, all right? So my critical t, remember that's the thing we're looking up on the table. And in my analogy of hurdler and hurdle, this was the hurdle, right? So this is the thing that you have to clear. If you want to be able to say that you have a statistically significant difference, you have to have enough evidence to clear this bar. So this is the hurdle, the bar. Now, what has to clear it? Remember we talked about the hurdler. So I'm going to put that in here. The hurdler has to clear the hurdle. Well, let's take a look. We have a critical t for our two-tailed test of 2.03, right? 2.03. That's the bar we have to clear. But our t statistic, look at that. It's 0.05. I mean, that's right, almost like the hurdler has like fallen on the ground and he's like crawling under the hurdle, right? It doesn't even come close to clearing the bar. So let's think about then what that means. What that means is if our hurdler can't clear the bar, there's just not enough evidence to meet a threshold to say that we can reject the null. So if there's not enough evidence to say there's a statistically significant difference, then do you agree our conclusion here is that we would fail to reject the null hypothesis, right? Now, I know that that's really weird language. I understand that it's weird to say fail to reject the null hypothesis. Why don't we just say we accept the null hypothesis? Well, I'm not exactly sure, and I should probably go in search of this because I get this question a lot. But saying that there's not enough evidence to reject the null hypothesis isn't exactly the same as saying there's enough evidence to accept the null hypothesis. Those are semantical differences, but they are meaningful in statistics. So our hurdler did not clear the hurdle. Therefore, we failed to reject the null hypothesis, again, at our 95% level of confidence, right? Now, how do I know 95% level of confidence? Well, remember, that's what we indicated with the alpha of 0.05, right? So let's just remind ourselves that we had an alpha of 0.05. And when we have an alpha of 0.05, that means we want to be 95% confident. In other words, we don't want to have any more than a 5% chance of making an error. Okay. Now, I know that you understand that there's also this thing called a p-value. Let's highlight that for a second. Our p-value is 0.96. Now remember, a p-value is telling you the chance of making an error. It's the chance, I believe it's the type 1 error, so it's the chance of making an error. In other words, failing to reject the null hypothesis when it's actually true. Well, look at that. There's a 96% chance that we would make an error here. So this is not good results, am I right? I mean, it's fine because I don't really care what the results are for male and female, but if my goal was to claim there was a statistical difference, there'd be no evidence of that. But also, guys, use some logic. Let's come back here and look at our means. Our mean for female is 82, and our mean for male is 81.82. Those means are almost identical, right? We can eyeball this and probably get a pretty good sense that given how close those means are, it's unlikely that there's going to be enough evidence to say that there's a difference. So that's what's going on here. Our means for females and our mean for male is very close. It's so close that we cannot claim that there's a statistically significant difference in means. In other words, we're failing to reject the null hypothesis. There is not enough information to say that we can reject the statement that the mean for males is equal to the mean for females. So it's really important, guys, that you be able to talk about this correctly. In your projects, you need to be able to state your hypotheses correctly. You need to, if you say it's two-tailed, explain why it's two-tailed. If you think it's one-tailed, there needs to be a reason why you think it's one-tailed, and it needs to make sense. You need to be able to show us that you can work with all three of these things, your T statistic that comes out of your data package, your critical T, we know that comes from a table, but it's being given to us, and the p-value. If all you do is memorize that if you have this p-value or more, then you fail to reject, and if it's less than this, you would reject, that's not going to get you a lot of points, because I know everyone can do that. So the quality of your explanation, and I tried hard here not to give you the language, so if you think my language isn't very precise, you're right, I'm kind of doing that intentionally. Otherwise, you're just going to spit back my own words. I want you to go back and make sure you really understand this. Now, how would I prepare myself for this? I would make sure that I can sort data like I did, right? If you can't sort the data, that's where you got to start. Second, you need to make sure that you can run your t-test correctly using your data analytics tool package. And that's going to require you to have that add in. And if you haven't added it in, you need to. Third, you need to make sure that you're looking at your confidence levels. Could I do more tests? Yeah, but I don't really need to. There's no reason to run a 99% confidence level, right? But what if I had found that there was a significant difference at the 95% level? Then I might ask myself, is there a significant difference at the 99% level? So I would say that when you find significant results where you do reject the null hypothesis at 95%, figure out how strong that result actually is. And of course, p-value is going to help you do that, but you should be able to speak intelligently about that. So if you don't fully understand the p-value, and I know I'm not being super precise here because I don't want you just taking the same words. I want you to have to go back and look at it and really craft your own language. But if you don't understand p-value, then you need to go review that. That's going to be super important. Now, let's look at one more thing. Your assignment might be asking you to do something with categorical dummy variables. And as you see, we've got France, USA, Russia, and Germany. So remember, if USA is my omitted category, it's really there. It's just not coded, right? Because look right here. If we have 0, 0, 0, 0, right? Oh, sorry, not this 0. If we have 0, 0, 0, then we know that's really a 1 for USA. But if I was going to ask you to compare the USA to all other countries, USA versus everyone else, that's just two categories, right? I might need to code that variable. That's not a variable I have at the moment. USA versus everyone else. Again, we're comparing two means. I would need a mean for the USA and I would need a mean for everyone else. And so I might need to put in that variable right here. So I might need to come in and code these ones so that I can code the USA versus not USA. You get the idea? But either way, understand, guys, that our hypothesis tests are simply comparing two means. It's comparing two means under our assumption of equal variances that we're not going to violate that assumption. We're letting Excel do the work. Your job is to make sure that you have your data sorted in a way that Excel can calculate those two means when you give it the ranges, and then you need very careful interpretation of results. Of course, this is after you've carefully thought through what your hypothesis is going to be and if it's one-tailed or two-tailed. So I hope that helps, guys. Not a lot to it. It's pretty easy to understand. So let me know if you have any questions about this. Thanks for listening and have a great day.